All right, this is day 50. Let's get it done. You are given an n by n binary matrix grid. You are allowed to change at most 1 0 to be 1. Return the size of the largest island in grid after applying this operation. Okay, an island is a 4 directionally connected group of ones. Okay, seems doable. So let's pick. Okay, so this is n by n. Okay, now let's make this 1 as well, and rest of them are 0. Okay, let's make an island here. Okay, now we have to make 1 0 to 1. Okay, we can pick any 0 and convert it to 1. Now brute force approach is to pick all zeros and get the maximum land size and then return that, but that would be outrageous. And what is the value of n? N is 500. Okay, okay. Now in this question, let's say I iterate from here. Now I find the land size to be 6. That's it, right? Now either I can convert this 0 to 1, then I get plus all of these guys. I can do this also, which will increase this guy and this guy. Okay. Okay, let's make these guys 0. Okay. I mean, I can do one thing. I can iterate like each island and then put the size of that island to that island, right? I mean, okay. So what I mean to say is Okay, I have this island, right? So I start iterating this island from this index, and I find that the size of this island is 1 2 3 4 5 6, right? So in another matrix, I'll replace all of these 1 by 6. This is 6 6 6 6, right? Now for this guy, this is still 1, so it remains 1, right? Now this island is also 1, so it'll remain 1. This is now 1 2 3 4 5 6 7 8 9, so this will be 9. Nine, nine, nine. Right? And this island is just 3. So it'll be 3, 3, 3. Right? That's all, right? Now it becomes easy. We just have to pick a 0 where the sum of neighboring elements is maximum. That's all. And we can't pick. Okay, now there is a problem here. And these should belong to different islands, right? 1 2 3 4. Yeah, I can't pick these guys. Okay. How do I check that? Okay. Along with the size, okay. Okay, this could be just group 1, this could be group 2, right? Right. So basically, I can, instead of putting the size here, so this is all right. I mean, this is okay. One thing I can do again is, instead of populating it with size, I can put a group number there. Group number, I meant like any unique integer. Let's take them as negative now, because it'll be easier to understand. So this is group -1, correct? This will be like group -2, something like that. Then this will be group -3, and so on. So for any 0, all the neighboring elements belonging to distinct groups, add their sizes, and whatever the max size is, return that. I think this makes sense. So let's do that. Now group num -1 4. Let's take, and also grid dot length. group map. Initially everything is 0, right? Now if this is the case, then do a DFS from ij on grid, and this is our group map populated with group number. Int I, int j, int grid g map. Now if I is less than 0 or I is greater than, let's pass n also, just to make it easier. If I is greater than equals n, or j is less than 0, j is greater than equals n, then return. Basically this is out of bounds. If grid I j is 1, then g map of I j becomes g num, and I can also return the size of this. If it is 1, then assign it to that group number, then return 1 plus DFS of I, j, and grid g map g num plus. Now we need this 4 times because there are 4 directions. I plus 1, I minus 1, j plus 1, and j minus 1. Easy. Now this will give me the size. Now I need to map this, right? So let's take a map of integer to integer, size map, size map dot put group num group size. Easy. Okay, now what do? We have to iterate over group map for int I equals 0, I is less than n, I plus plus for if group map of I j is 0. Let's take a set here of integer, right? Set of integer neighboring groups equals new hash set, right? Okay, let's keep it in a different function. Int get neighboring group sizes, group size sum. Now let's take this. If I plus 1 is less than n, then total. Okay, if I plus 1 is less than n, then ngh groups dot add g map of I plus 1 j. Now I have to do this 4 times. If I minus 1 is greater than equals 0, I minus 1, j plus 1, j minus 1. Okay. Now we need to iterate over this ngh groups, right? For integer g in neighbor groups, total size plus equals size map dot get g, and then return total size, and here size map dot put 0 0. Largest size, and this function call I j n, what else, group map and size map. Okay, why is this stack overflow? Something wrong happened. Okay. Oh. If g map of I j is not equal 0, then return 0. Six? How? But why is this 6, my friend? Yeah, so why is size of -1 at 6? What? Why is this? Okay. Maybe I need to check here. Yeah, it's 1, right? And what's the size map? Oh shit, okay. Group num needs to go. Group num minus minus. Size of group -1 6. Group -1 6. Wow, why? Why is it 6, my friend? Why is it 6? If grid ij is 1, then g map ij equals g num. Oh. If grid I j is 0, then return 0 as well. Yeah, there you go. There you go. But I'm concerned that this is pretty slow. Why is that the case? Okay. Yep, it works. Okay, so is there any better solution? Paint the picture. For each one in the grid, we paint all connected one with the next available color, 2, 3, so on. We also remember the size of the island. We just paint it, then we analyze all 0. Yep. Yep. Similar approach. It's n square, right?